A few notes that we need to take. Okay. Um, about adding and subtracting radicals before we begin. Okay, so here we go. Number one, we've got to simplify the radicals, if possible. Because obviously, if it's already simplified, we can't simplify it anymore. Okay? But before we add or subtract radicals, we have to make sure that they are simplified. Okay? Then, once they're simplified, then we can combine. And what we're combining are the coefficients. We're combining the coefficients. Just the numbers in front. Okay? Of the radicals. And they've got to be like radicals in order to combine them. Now let's talk and write down, because it'll be handy to know, what like radicals are. Like radicals have the same exact terms inside the radical, or the square root. Same exact terms on the inside. Okay? That's what like radicals are, or what they have. That's how we know that they are like. Okay? So it works the same way as it does with like terms. You can't combine them when we add or subtract. You can't combine them if they're not like radicals. Okay? So they have to be like radicals in order to combine them. Let's look at example 1. Okay. So 3 root 6 plus 3 root 6 plus 3 root 6. I'm looking at the radicals to determine if they're like or not. Root 6, this one is root 6, this one is root 6. So those are all like radicals. So I can combine their coefficients. 3 plus 3 plus 3. The operations in between tell me what to do with them. So 3 plus 3 is, plus 3 is, so 9. Now, if they are like radicals, I've got to keep them that way, so I just bring down what the like radical is into my answer. So 9 root 6 is my answer. Now, I want to always, when I can, check to make sure I have the correct answer. Remember what I said yesterday about when we have coefficients, we're just going to type in the problem, type in our answer, and make sure that our decimals match exactly. So let's do that now. 3 root 6. Remember, I've got this flashing arrow. It tells me to arrow out when I'm done. So make sure you arrow to the right before you keep going. Otherwise, it's all under the same radicals. Weird. plus 3 root 6. I'm going to push enter, and I've got this 22 point blah blah. Now, I'm going to type in my answer. 9 root 6. I'm going to enter there. Do I have the same exact decimal for both of those? Yes, we do. So we know that we simplified it correctly. Okay? All right. So just as a reminder, how we check our answers. Okay. Now let's go down to example 3 here. Six does not have a perfect in it. 3 doesn't, and 3 doesn't. So I don't have to simplify those. But what I'm checking for is which ones are the like radicals. The root 3s. This is root 6, but I've got a root 3 and a root 3. Those are my like radicals. So when adding or subtracting with radicals, combining with radicals, I'm not always going to get this pretty little answer like this. Sometimes it's going to look like example 3 here, where negative 2 root 6 is just going to come straight down because it doesn't have a like radical, so I just bring it down. Okay? And then I look at, now this is negative, what number goes here? That invisible 1. That invisible 1. So don't forget that that is there. That's the coefficients. Those are the coefficients. So now I have negative 1 minus 1, and I get negative 2, keep the radical. And this is the final answer. I cannot combine these two here because they're not the same. Yes? Why would I get a negative 2 here? Because negative 1 minus 1 is negative 2. And what's inside the radical remains the same. Excellent. Thank you for asking. I like it when you clarify things. Okay. Very good. Any other questions about number 3? I'm only combining coefficients. What's inside that radical has to stay the same. All right, let's look at 4. So example 4. Is there a perfect in 12? Yes, there is. What is it? So 4 times 3. You're only looking for perfects. 6 is not a perfect square. It's not a perfect root. Okay? Plus, simplifying has not changed. It works the exact same way as we did from the beginning of the week. What is my perfect in 27? 9. And then it's times. So now I'm simplifying that. Here we go. The root of 4 is 2. 3 stays in because it's not perfect. Remember, only perfects get to come outside. Plus the root of 9 is 3. 3 stays inside. Just simplifying just like we have been doing. How we simplify them does not change. Do I have like radicals? Yes, because they are both root 3s. I'm only looking at the root, what's inside that radical, to determine if they're like or not. So what is 2 plus 3? Keep the root 3. Questions? Okay. Number 5. I want for you to get that answer, please. Simplify. And get your answer. Remember to divide by those perfect roots to find your perfects. Okay? What is my perfect in 8? 4. And then it's times 2. What is my perfect in 45? 9, and it's times. I agree. So, what is the root of 4? How many of you got that? Nice. Remembering from what we did yesterday, which is if I have an existing coefficient, when I take the square root of the perfect, when I bring it out, I multiply them. Excellent. And the root of 9 is 3. Keep the root 5. Are these like radicals? No, they are not. So this is my final answer. How many of you got that correct? Okay. Just need a little reminder. Okay. If I have an existing coefficient, I'm going to multiply by what's already there when I bring that out. Okay. Number 7. Let's try number 7. You should find perfects in all 3 of these radicals. So you're going to need to simplify all 3 of them. So make sure you find those perfects for 20 and 12. Once you have your answer, check it. Type in the problem, type in your answer, and make sure it is correct. Okay, then you can check with mine to make sure that you've simplified it correctly inside. Okay, are we good so far? Which ones, because there are only 2 of them, which 2 are the like radicals? The root 5s. I agree. What is negative 6 minus 6? I'm sorry, negative 6 plus 6? 0. How many of you got that correct? Tell me what went wrong. On this one? Oh. I'm with you. Okay, but keep in mind, if my coefficients make a 0, the whole thing is 0. Okay, there we go. Because really what it is negative 6 root 5, take away 6 root 5, it all goes away. Okay? Good, thank you for sharing that so I can say that. So when you combine these, if your coefficients are a 0, it's 0. The whole thing goes away, and then all you have left is what's left. Okay? What? Yes. Yeah, because when I'm combining, if it's the same opposite sign, it's going to go away. I got you. Okay, I got you. But you can get zeros here. Okay, they can cancel out. They can create a zero. So just go ahead and mark through them, and they're gone. Okay, very good, very good. Anybody else? Questions or comments? Nice. Okay, let's look at number 6. This is the only one I put on here, but I just can't stand it if I don't have a variable somewhere. Ridiculous. Okay, first of all, when I look at this B, are there enough B's here to move one out? Yes or no? Nope, there's just one. How many do I have to have in order to put one outside the radical? Two, because it's a square. Square means two. I only have one in each radical. So there is not going to be any variables on the outside. But don't forget they have to stay inside. Okay? So when I look at number 6, what is the perfect in number 6? What is it? Find it for me, please. 25 times what? I agree. Don't forget the B. Okay, so just bring that B along for the ride. Okay? Plus 3, and what's my perfect in 20? And it's times 5, keep the B. Okay? And then minus, what is my perfect in 45? Times 5, keep the B. Look how much faster you're getting at recognizing those perfects in those numbers. Just saying. Okay, so this one is going to be 5 root 5b plus 6 root 5b. Root of 4 is 2. 2 times 3 is 6. Okay? Minus 3 root 5b. Are all of those like radicals? What's this one? This is root 5b. What's this one? What's this one? So, what's inside the radical, if they're exactly the same, then they are like radicals. So now, 5 plus 6 is 11, minus 3 is 8 root 5b. There's always one. There's always one in the group that can't add or subtract. It's okay. It's okay. Y'all know most of the time it's me, right? Okay, I'm just saying. Okay, so my final answer is 8 root 5b. Okay? Make sure that you are simplifying your radicals completely, if possible. Then combine the coefficients of like radicals only. Okay? I want you now to work number 8. Work number 8. Check your answer when you're done. I'm watching to see if you're typing it in to check your answer. Type in the problem, get your decimal. Type in your answer, get your decimal. Let's tell you work number 8. Let's tell you work number 8. I mean, you got it correct. Any questions or comments?
Um, so when you rewrote it, it was making you so say why am I looking um where you have to
Because 3 is not a perfect and 2 is not a perfect. Okay? Keep asking me, because that's good. I appreciate the question. So we only break them down if they're a perfect. Okay? And some of those, once we start, the more we work with them, the more you'll recognize like 6 is not a perfect. I mean, it just takes a little bit of time to recognize those immediately. Thank you. Any other questions or comments? 9 minus 2. Ah, see it now? Because these are the only two that are perfect. I mean, I'm sorry, that are like radicals. Good question. Anybody else? Questions? Okay, you're going to type in the problem just like it is. Push enter. It'll give you a decimal, and then type in the answer that you got. Push enter, and you should get the same exact decimal. Thank you for asking. Look at problem number 9. Anybody notice something immediately? So I've got, these are like, I agree. The root 5s are already like radicals. What do you notice about them? They make a 0, exactly. So I do not have to work with those from the onset. So absolutely. So then I'd look at what was left and I'd go, oh, I know I can simplify that and get 6 root 5. Okay? So if you see from the problem itself that I have like radicals that will combine to make 0, go ahead and mark those out and only work with what's left. Okay? Questions? I want to give you time to work on your homework. Okay?